Hello students, welcome to EPG Pathshala. I am Dr. Anjali Sharma from University of Delhi. Today we are going to talk on module Units and Dimension under the paper Electromagnetic Theory. So after completing this module, the students will be able to find reasons for so many systems of units and dimensions in electromagnetic phenomena, various equations of electromagnetism written in a system independent way, various constants of proportionality that enter into these equations, some of the many systems which were in use and the values of these constants in those systems, table for conversion of equations from one to the other system for two of which are still widely in use. When dealing with the physical quantities, we have to employ a system of units and dimensions to measure them. This is of course a phyllotra of units employed, some in general and some for specific purposes. They can sometimes become confusing, but nowhere are they more so that in electromagnetic theory, where historically a large number of different units and dimensions have been employed. Even now many units are in common use. These are the International System of Units, that is also known as SI system, Gaussian system of units, Heaviside-Lorentz system of units, various natural systems of units, ESU system and EMU system. The SI system is the modern metric system and is the preferred system now. In the context of electromagnetism, it is called the MKSA, that is meter, kilogram, second, ampere, or the rationalized MKSA system. The other system still commonly used in electromagnetism is the Gaussian system, especially in cosmology, astrophysics, particle physics and the fundamental studies. Heaviside-Lorentz and the natural system of units are still often used in electromagnetism, though not much in classical electrodynamics. In the natural system employed in quantum electrodynamics, we take C is equals to H cross equals to 1 and avoid writing a large number of these factors which appear in most quantum electrodynamic calculations. These factors are restored at the end from dimensional considerations. Let us try to understand the problem of multiplicity of systems of units by considering the well-known phenomenon of gravity. In mechanical phenomenon, there are three fundamental dimensions: mass, length and time, and all other mechanical quantities can be expressed in terms of these. It is an experimentally established fact that the force of gravity between two bodies is directly proportional to their mass and inversely proportional to the square of the distance between them. F is directly proportional to m1 m2 divided by r square, which implies that F is equals to g m1 m2 divided by r square. Since the dimension of mass, length and time are fixed, the unit of the force follow from them in terms of its definition. Force is equals to mass into acceleration. There is a problem here also, but let us not delve into that. The dimensions of the constant g are now fixed. The magnitude has of course to be determined by actual measurements. Let us have a little digression here. The force is that thing which enters into the law of inertia. There could be various origins of force between two objects. It depends on certain property of those objects called charge. In this sense, the electrostatic force is due to the electric charge E of the body. The gravitational force is due to the gravitational charge G of the body, and so on. It is again an experimental observation that the gravitational charge of a body equals actually proportional to the initial mass of the body, the quantity that enters into the law of inertia. In this spirit, the law of gravitation should be rewritten as F is equals to G into G1 G2 divided by R square. Experimentally, when we measure the force, we can obtain only the value of G dash G1 G2 and not of G dash and G individually. Conceptually, G dash is a property of the force and G is of the body. Therefore, it will be nice to separate the two and define their units and dimensions independently. Further, the concept of field, the force per unit length, that is F divided by G1 is equals to G dash G1 divided by R square. Now students, let us study about the system independent relations. The starting point of each system of units has been the force between objects. In the present context, we have the force between two charges or a force between two currents. Historically, the latter was written as force between two magnetic monopoles. Let us begin with the Coulomb force between two charged particles. Experimentally, it is known to be inversely proportional to the square of the distance between two point charged particles, and in the light of discussion above, we write this as Fe is equals to Ke Q1 Q2 divided by R square, where Q1 and Q2 are the electric charges of the two particles and Ke is a measure of the strength of the force, which is a property of the nature of force. The system of units will depend on how we assign dimensions to the two quantities, the charge and the coupling constant Ke. We are free to choose independently dimensions of Q and coupling coefficient Ke through dimensions of Ke square, and these are fixed. Two infinitely long conductors carrying currents I1, I2 experience a force per unit length proportional to the two currents and inversely proportional to the distance between them, which is also known as the Ampere's law. So F mag is equals to 2 km into I1, I2 divided by R. The factor 2 in the equation is only for convenience. We are free to choose independently dimensions of L and coupling coefficient Km through dimensions of Kmi square, which are fixed. However, the situation is not totally chaotic. The dimensions of the two constants Ke and Km are related to each other and only one of them can be chosen arbitrarily. So, considering the dimensions, we have Fe divided by F mag is equals to L equals to Ke Q square divided by L square into L divided by Km I square, which is equals to Ke by Km into T square by L, which further implies that Ke by Km is equals to L square T raised to power minus 2 is equals to V square, which implies that fixing units and dimension of either fixes everything. From experimental measurements of the two forces, numerically under root of Ke by Km equals to the velocity of light in vacuum, that is under root of Ke by Km is equals to c. So the continuity equation del dot j vector plus del rho by del t is equals to 0 in all systems. The magnetic fields. For the electric field, we had E is equals to Fe by Q is equals to Ke Q by R square and is thus fixed. The moment Ke is fixed. However, an electric current gives rise to the magnetic field, and we all know from the above equation that at this stage the magnetic field produced is proportional to the current. So B is equals to directly proportional to F mag divided by A, which is equals to 2 kb km into I by R, where kb is another proportionality constant to be chosen arbitrarily. Once the dimensions and units of kb are chosen, those of B are fixed. So the equation also gives a relation between the units of E and B, and B is equals to kb km I divided by R, which is equals to kb km q by RT, which is further equals to kb km ER by KET is equals to kb into E by C. Now look at the Lorentz force on a charged particle in an external electromagnetic field. The magnetic part of the force is proportional to V cross B. The constant of proportionality will depend on the system of units chosen. So FL vector is equals to QE vector plus alpha times V vector cross B vector. So V vector cross B vector by KB has dimensions of E vector, and therefore demanding that all the terms in an equation must have the same dimensions. So we find that alpha is equals to 1 divided by KB, so that FL vector is equals to Q E vector plus Q by KB into V vector cross B vector. Now fixing dimension and numerical value of Ke, Coulomb's law fixes dimension and numerical values of Q. Equation 3 fixes the dimension and value of Km, which fixes the force between the two currents. Next we choose a value for Kb. This fixes the dimension of B, and from 4 the value of B can be observed. Now let us study about the Maxwell's equation. Let us look at the Maxwell's equation in their differential form, which are obtained from Coulomb's law, Ampere's law and Faraday's law, and the fact that there are no magnetic monopoles by the application of theorem of vector analysis. The first one is Gauss law, which is direct consequence of Coulomb's law and written as del dot E vector is equals to 4 pi Ke rho. The second equation is Ampere's law. Along with the displacement current term introduced by Maxwell, it reads as del cross B vector is equals to 4 pi Kb Km J vector plus beta del E vector by del T. The factor Kb Km comes from earlier equations, and beta is defined as follows. Now on taking the divergence, we use the continuity equation for del dot J vector, and from Gauss law we can obtain that beta is equals to Kb Km by Ke, which implies that del cross B vector minus Kb Km by Ke into del E vector by del T is equals to 4 pi Kb Km into J vector. Similarly, from Faraday's law, we have del cross E vector plus Kf del B by del T is equals to 0. And finally, we have the absence of magnetic monopoles, that del dot B vector is equals to 0. Now let us see the relation between Kb and Kf. Now these were the Maxwell's equations in vacuum and include all the constants. In the absence of source, Ampere's law takes the form del cross B vector minus Kb Km by Ke into del E vector by del T equals to 0. So on taking the curl of this equation and using the other Maxwell's equation leads to the wave equation, that is del square B vector minus Kf Kb Km by Ke into del square B vector by del T square is equals to 0. Now this is the equation of wave propagating with velocity under root of Ke divided by Kb Km Kf. Now knowing experimentally that electromagnetic waves travel with the speed c in vacuum, we have under root of Ke divided by Kb, Km, Kf is equals to C. But we already know from earlier equation that under root of Ke by Km is equals to C, and thus Kb into Kf is equals to 1. The product Kb Kf is dimensionless and numerically equals to unity. Therefore, only 2 of the 4 constants are independent. So let us choose Ke and Kf as independent. We finally get the Maxwell's equation in free space as del dot E vector is equals to 4 pi Ke rho. Second, del cross B vector minus Kb by C square into del E vector by del T is equals to 4 pi Kb Ke by C square into J vector. And third, del cross E vector plus 1 divided by Kb into del B vector by del T equals to 0. And fourth one, del dot B vector equals to 0. The various systems differ in their choice of numerical values and dimensions of the remaining constant Ke and Kb. Here on the screen you can see a table where we have listed the values of the 4 parameters for the Gaussian, the SI units that are currently widely in use, and some other systems which have been used in past and are still used sometimes. The system of unit used for mechanical quantities along with the electromagnetic quantities is also different for different systems enumerated here. Whereas the SI system listed in the table use the SI system in MKS for mechanical quantities, all other use the CGS system. Also, the SI system has 4 fundamental dimensions: length, mass, time and current, and all other have only 3 dimensions, that is length, mass and time. All electrical and magnetic quantities are expressed in terms of mechanical quantities only. In this spirit, the law of gravitation should be rewritten as F is equals to G dash into G1 G2 divided by R square. Experimentally, when we measure the force, we can obtain only the value of G dash, G1, G2 and not of G dash and G individually. Conceptually, G dash is a property of the force and G of the body. Therefore, it will be nice to separate the two and define their units and dimensions independently. Further, the concept of field, the force per unit charge, that is F divided by G1 is equals to G dash into G2 by R square, is one of the most important and fruitful concepts in physics. To assign dimensions to the field, any field must assign dimensions to G dash and G independently. That is, where many different systems of units arise, the problem did not occur in the mechanics because G happened to be proportional to M. The same units could be chosen for G as for M. As a result, only one new quantity G was introduced and its dimensions got automatically fixed. Historically, the two phenomena, electrostatics and magnetostatics, developed independently and had their own system of units. Till then, the problem was still manageable. When the connection between two was discovered, the confusion became worse and confounded because now the two systems had to be reconciled properly. D vector is equals to epsilon naught E vector plus lambda P vector. H vector is equals to 1 divided by mu naught B vector minus lambda dash M vector. Here, D vector is called as the displacement vector and H vector is called as the magnetic field intensity. Now 4 new constants have appeared in these equations. They will have different values and dimension in different systems. Dimensions of p vector and m vector are known from their definitions. That is, p vector is equals to small p vector divided by L cube is equals to q L raised to power minus 2. M vector is equals to small m divided by L cube equals to I L square by L cube equals to I L raised to power minus 1. Nothing is gained by making D and P or H and M have different dimensions. So we choose lambda and lambda dash to be dimensionless number with numerical value unity in Lorentz Heaviside and SI system and 4 pi in the others as mentioned above. So for linear isotropic medium, the constitutive relations are written as D vector is equals to epsilon E vector plus H vector is equals to 1 divided by mu into B vector. Thus, epsilon naught and mu naught are the vacuum values of epsilon and mu. The continuity equation and the Ohm's law take the same form in all the systems enumerated above. So we have del dot J vector plus del rho by del T equals to 0 and J vector equals to sigma E vector. Now let us see the conversion table between SI and Gaussian systems. The two main systems which are still quite widely used in the literature are the Gaussian and the SI systems. Equations appear quite different in the two systems, and it will be useful to be able to convert equations from one system to the other system. The table given on the screen lists the various conversion factors required to obtain equations in one system from those written in the other. The factor C appears explicitly in equations written in Gaussian system. The first entry means that the factor C appears explicitly in equations written in Gaussian system. The first entry means that wherever the factor of C appears, replace it by under root of 1 divided by mu naught epsilon naught to obtain the corresponding equation in SI system. To convert equations written in the SI system into Gaussian, first make proper replacement for all electromagnetic quantities. In any factor of mu naught epsilon naught is left, replace it with 1 divided by C square. Let us see some examples. First, the Lorentz force equation in SI system is F vector is equals to Q into E vector plus Q into V vector cross B vector. So to obtain the equation in Gaussian system, replace Q by 4 pi epsilon naught raised to power half Q and E vector by 4 pi epsilon naught raised to power minus half E vector and B by mu naught by 4 pi whole raised to power half into B vector. Hence in Gaussian units we get F vector is equals to Q bracket E vector plus under root of epsilon naught mu naught into V vector cross B vector bracket close, or F vector is equals to Q times E vector plus Q by C V vector cross B vector. Example number 2. In Gaussian units, the modified Ampere's law reads as del cross H vector minus 1 by C del D vector by del T equals to 4 pi by C J vector. So, to obtain the equation in SI system, make the following replacement. H vector by 4 pi mu naught whole raised to power half into H vector, C by 1 divided by under root of mu naught epsilon naught, D vector by 4 pi divided by epsilon naught whole raised to power half into D vector, and J vector by 4 pi epsilon naught raised to power minus half into J vector. Hence in SI unit the equation becomes del cross H vector minus del D vector by del T equals to j vector. Similarly, in example 3, Faraday's law in SI system can be written as del vector cross E vector plus del B vector by del t equals to 0, and in Gaussian system it can be written as del cross E vector plus 1 by C del by del t of B vector equals to 0. Maxwell's equation in a medium. So far as we have discussed the electromagnetic field in free space only, we now wish to extend the discussion to fields in a medium. In a medium, apart from the field due to free charges and currents, field also arises due to polarization. P vector, electric dipole moment per unit volume, and magnetization M vector, magnetic dipole moment per unit volume of the medium. We account for these additional fields which may be intrinsic to the medium or may be the result of external fields by defining the auxiliary fields D vector and H vector through the consecutive relations. D vector is equals to epsilon naught E vector plus lambda P vector, and H vector is equals to 1 divided by mu naught B vector minus lambda dash M vector. So students, let us now summarize what we have learnt in this module. In electromagnetism, a vast number of different systems of units and dimensions have been used in the past. Reasons for so many systems of units and dimensions in electromagnetism are explained. Various equations of electromagnetism are written in a system-independent form by introducing 4 constants of proportionality that appear in these equations. It is explained that of the 4, only 2 are really independent, and how giving different values and dimensions to these constants lead to different systems. The values of these constants are tabulated for 5 of many systems that had been in use in the past. By and large, only 2 of those systems are in use now, Gaussian and the SI. The table of course includes these 2. The equations appear quite different in these 2 systems, lead to confusion to students and scholars as well. A table is provided for conversion of equations from one system to other and explained with examples. Thank you.